Next one here, we have properties of irrational numbers. Let's write down a few notes here. Rational numbers and irrational numbers. Rational numbers are numbers that can be written as a numeric fraction or a repeating decimal, okay, which can also be rewritten as a numeric fraction. Okay, so rational numbers are numbers that can be written as numeric fractions or repeating decimals. Okay, so that would be things like a 5, a -5, a 5/2, okay, a 5.2, or a 5.22 repeating, okay, something like that. Irrational numbers are the exact opposite, okay, cannot be written as a fraction or a numeric fraction. Or repeating decimal. Okay, so the ones that are going to show up in this worksheet are things like radical 2. If you do put that in a calculator, and if you have access to the calculator on a prompt like this, check it out. Second square root of 2, excellent, thank you, Zach. Let me put my approximate button, see how it goes 4, 1, 2, 1, 3, 5, 6, 2. It doesn't start to repeat the pattern at all. That makes this one irrational. Okay, here's another one, second clear. Let's do pi. Pi, if you look at the approximate value, it's 3.415, blah, 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 blah. Okay, let's see here. E, that's another one we've done in advanced math, and math 3, 2.718, 2818. It looks like it's starting to repeat, but it really isn't. There's going to be another digit right after that 8. In fact, I believe that 8 is rounded. So this one is not a repeating decimal. Okay, and then I is the square root, so the negative, so that one's just imaginary. Okay, so E, also anything that has a radical in it, so like 3 plus root 2, if I plug that in, 3 plus second root 2, it's still a non-repeating decimal, okay? Or anything like this where you turn a rational and it has that in it, and the denominator or the numerator. Okay, so let's take a look here. Choose two different numbers whose sum when added would be irrational. Okay, so I have an irrational here. Anytime I add it with any other number, it's going to be irrational. Okay, so I have my 3 root 2. I could pick any one of those. I'm going to pick plus -5. But I could have said plus 2/3 or plus 1/3. I could even say plus 1/8 or plus root 8. But if you see this one, you better check it. Okay, so let's try that one. Number 1, 3 root 2 plus root 8. I can reduce that one. I have 3 root 2 plus 2 root 8. If I add them, I get 5 root 8. But 5, oh sorry, I did that wrong. That would be 2 root 2. So then when you add them, you get 5 root 2. And 5 root 2 is still irrational. Okay, so So that's a good example there, but I could take that root 8 because when it's reduced, it's still a radical. I could add that with any number. Okay, so I could have said root 8 plus any number. So like the fraction would be fine. But if you add the fractions together, a fraction plus a fraction is still a fraction. You're not going to end up with a root or a pi or something like that. Okay, so a key word here was add. Add numbers. Okay, so here it's going to say product, and then when multiplied. So we're going to multiply things now. Okay, so I want it to be rational. So anytime you have two numbers, like the easy one might be this one plus this one. That would definitely work because 2/3 plus 1/3 is 1. Okay, but you could have a lot of other ones also. Dang it, it's not supposed to be, it's supposed to be multiply. Dang it. Thank you, Michaela. And so that would be 2/6, okay? Which is still rational. Now here, if you wanted to go with those radicals, I cannot multiply this with any of my rationals because it'll still be irrational. But if I multiply them together, let's see, I would do my number 2, 3 root 2 times root 8, that would be root 16, and root 16 is 4. 3 times 4 is 12. That is rational, so that one would work. Now, it's not saying to pick the most difficult one, so go for the easy one, okay? So I'm going to put that one. This is or this one I put 3 root 2 times root 8, okay? Let's see, let's put my 2 back in there. Okay, so I think there's up to 7 choices on that one. This one, I think there's probably a lot of choices on that one as well. Okay, so for these boxes here, we're selecting the appropriate box to identify each expression as rational or irrational sum. Okay, so for rational, I'm going to use R, and for irrational, I'm going to use IR, just so I don't have to rewrite like everything. Okay, so 4 plus 4 would be 8, which is rational. Okay, 4 plus 1/3 is 4 1/3. That is rational, and I could do that as do a common denominator and get 12/3 plus 1. Okay, but root 3 plus 4 is going to be irrational because I can't actually add them. Pi plus 4 is going to be irrational because if I add a non-repeating decimal to a number that has no decimal, it's not gonna work. Okay, or it's going to continue to be irrational. So here, when I add them, I get the same thing here. So that's rational. When I add these two, I get 2/3. That's rational. When I add these, it's going to be irrational. Okay. Here, I'm taking that irrational and I'm adding them. So that's going to be irrational. Okay. Irrational. Here, if I add root 3 with root 3, okay, thank you. I get 2 root 3, which is still irrational. Okay, here if I go pi plus root 3, that's definitely irrational. Pi plus 4 is irrational. 1/3 plus pi is irrational. Root 3 plus pi is 2 irrationals added together. That's still irrational. And then here I have pi plus pi would be 2 pi. That is still irrational. Okay, over here it says product now. So doing the same thing. 4 times 4 is 16. So that's rational. 4 times 1/3 is 4/3. So that's rational. 4 times root 3 is 4 root 3. So that is irrational. Same thing, this will be irrational. This one though, I can actually reduce that cube root, so that's a little sneaky. this one here reduces to be -3. So does this one. So -3 times 4 is -12, which is rational. This would be 4 over 3. This would be 1 over 9. This would be root 3 over 3, irrational. This would be -root 3 over root 3, or over 3, so that would be irrational. This would be 1/3 times -3, which would be -1, that is rational. Okay, root 3 times 4 is irrational. Irrational. Root 3 times root 3 is root 9. Root 9 is 3, so that is rational. Root 3 times root 3 is 9, but now I have a negative, so that's going to be -3. It's still rational. I'm going to have -3 here times root 3. That's -3 root 3, which is irrational. Okay. Same thing here. Irrational. Irrational. Root 3 times root 3 is root 9. That will be rational. Rational. Irrational. Okay. This is -3 times 4. That's 12. Rational, rational, irrational, irrational, and then -3 times -3 is +9, that is rational. Okay, look here at the next part. I'm gonna select all, so that means there's probably more than one. Okay, so numbers that will produce a rational number when multiplied by 7 root 5. Okay, I'm going to use my stretch paper here, this little piece here. Okay, so it was 7 root 5. Okay, so 7 root 5, I'm going to multiply it by -1/5, and I want to produce a rational. This one would end up being -7 root 5 over 5. That's irrational. And I want rational. Here I have 7 root 125 times 7 root 5. That'd be 49 times, that would end up, this one I like shrinking it down. This is 5 to the 3rd, and then that's 5 to the 3rd times 5. So that would be 5 to the 4th, and so if I square root that, I'd get 49 times 5 squared. I mean, not inside a radical anymore. Okay, so that'd be 49 times 25, which is going to be rational. 49 times 25. Okay, so that one will work. Okay, this one, it says multiply, right? It does say multiplied. Okay, 7 root 5 times 5 plus root 5. Here you have to distribute. So I'd have 7 times 5 and a root 5. So 7 times 5 is 35. I'm going to erase that 7. And 7 root 5 times 5 is 7 times root 25. That'd be 35 root 5 plus 7 times 5. Okay, and I still have that number in there, which makes it irrational. So I'm going to scratch off C. Okay, and then for my last one here, I have D3 9 over 5 times 7 root 5. Okay, so my 7 and 3 multiply to be 21. I can say that this is 5 over 1. So 9 times 5 is 45, but I'm going to divide by 5, so that'll end up being 9. Square root of 9 is 3. and 3 times 21 is rational. So I have 2 answers, B and D. Okay, next one. Select the appropriate box for each expression as being rational or irrational. Okay, this one would be irrational because I can't add those. This is a repeating decimal or solid decimal, so that would be rational. This one, square root of 4 is 2. So 2 plus 17 is going to be a rational number. Here it says I'm multiplying, so that'd be negative 100 times square root of 100. Square root of 100 is 10, and negative 100 times 10 is rational. Okay, so we only had one irrational. Awesome.